we're going to take a look at the graph of the tangent function. Now, in order to do this, we're going to use some techniques we saw earlier in precalculus, namely the techniques we use for graphing rational functions. Now, with rational functions, you might remember that there are zeros and there are vertical asymptotes, and you might also remember this sort of sign analysis thing. We'll get to those when we get to it. So here we have the graphs of the sine and cosine function. And of course, we want these things because we're interested in the tangent function, and the tangent function is built out of the sine and cosine function. And so we have here a fraction, and we want to figure out the graph of this. And so the idea is that we need to look for vertical asymptotes and zeros. We'll start with the zeros. How do we get a zero for a fraction? Zeros for a fraction happen when you have a zero on the numerator. So the numerator is a sine function. Where is the sine function equal to 0? It's equal to 0 here at negative pi. It's equal to 0 at 0. It's equal to 0 at pi and at 2 pi. And in fact, it's 0 at every integer multiple of pi. Vertical asymptotes come from where the denominator is equal to 0, at least when the function has been completely reduced. So where would we expect to find the vertical asymptotes here? Well, look at the cosine function. Where is the cosine function equal to 0? Negative pi over 2, pi over 2, 3 pi over 2, and so on. So there'll be another one here at 5 pi over 2. So this is the first step. We find the zeros and the vertical asymptotes. Then to get the rest of the shape, what we'd have to think about is we have to think about whether the function is positive or negative in each of these little intervals. So everywhere between the 0 and the vertical asymptote and the vertical asymptote and 0, will the functions be positive or negative? Again, we're going to look at this fraction. We know that if we have a fraction, if it's positive divided by positive or negative divided by negative, the result will be positive. And you have a mix, positive over negative or positive, it will be negative. So what we're going to do is we're going to just sort of work our way through each of these intervals and ask ourselves the question, will the result be positive or negative? So let's go ahead and start all the way here on the left. Over here, between negative pi and negative pi over 2, we have a negative value for the sine function and a negative value for the cosine function. That means the end result will be positive. And when you're positive approaching a vertical asymptote like this, it's going to do something like that. Now, the exact shape isn't something that we can analyze at this point, but we're basically looking for the general shape here. It's going to be approaching a vertical asymptote on the positive side on the left of negative pi over 2. In this interval here, negative divided by positive. Sine is negative, cosine is positive. Negative divided by positive is negative, so we'll be coming up from this side, approaching the 0. And we're just going to repeat this process going to the right. Positive over positive is positive. So it's going to come up like this. Positive over negative is negative. And the next interval is negative over negative, which is positive again. Negative over positive. And then this next one will be positive. And from this analysis, we can get the general shape and some of the general properties of the tangent function. We see that it's equal to 0 at the multiple integers of pi. And it has vertical asymptotes at sort of the half pi, so plus or minus pi over 2, 3 pi over 2, 5 pi over 2, and so on. And it has this basic shape that it's going, it's an increasing function between these vertical asymptotes. The analysis of the cotangent function is very similar to that of the tangent function. Cotangent of theta is going to be cosine theta over sine theta. And so we'll look at the same graphs, but now we're going to swap the roles. I switched the order of these two, so now cosine is up and sine is on bottom to sort of match the function. All right, so what are we looking for? We're looking for zeros and vertical asymptotes first. So the zeros of this function, the cotangent function, are where the numerator is 0, and the numerator is 0 at when cosine is equal to 0. So 0 is going to be here at negative pi over 2, 0 at pi over 2, and a 0 at 3 pi over 2. Vertical asymptotes happen where the denominator is equal to 0. The denominator is the sine function, so it's where the sine function is 0, which is negative pi, 0, pi, excuse me, and 2 pi. And now we do the sine analysis. So cosine over sine. Negative over negative is positive, so it's going to be approaching that asymptote in the positive direction. Then we have positive over negative, which is negative, comes down this way. Positive over positive, negative over positive is negative. And if we do it one more time, negative over negative is positive, and then positive over negative is negative. And this is the graph of the cotangent function. We're going to analyze the tangent and cotangent functions just a little bit further. One of the first things that we'll notice about these is that the period is only pi, as opposed to 2 pi for the sine and cosine functions. Another thing is that these two functions are reciprocals of each other. So if we know the graph of the tangent function, we ought to be able to get the graph of the cotangent function by just using some logic. So let's see how that would work. Remember that when you take the reciprocal of a fraction, the numerator becomes the denominator becomes the numerator. Another way of saying that in terms of these graphs is that zeros become asymptotes and asymptotes become zeros. And so we can see that the 0 here at t equals 0 and negative pi and pi, that those become vertical asymptotes. And these vertical asymptotes at negative pi over 2 and pi over 2 become zeros. And so if you know the tangent function, you can actually get the cotangent function by just using this trick. The shape of this is also determined by the sign analysis. So when you take the reciprocal of a fraction, it does not change signs. So here in this interval from 0 to pi over 2, it's still positive. And here in the next interval from pi over 2 to pi, it's negative, and so it stays negative right here. Oh, sorry, this side. It stays negative right there. And so you can use this to deduce information about the cotangent function from the tangent function, which means that if you understand the tangent function, you don't need to necessarily memorize another set of facts for the cotangent function. You can just use this and use some reasoning to reconstruct this.